Assalamu alaikum students. This is your fourth lecture on water supply and sanitary engineering. In this lecture, you will study about the numerical type questions on pH value, alkalinity and hardness of water. Now before solving the numerical type questions, here are some important points you need to know. The equivalent weight of calcium carbonate is 50 and the equivalent weight of calcium is 20 and that of magnesium is 12.2 and the equivalent weight of strontium is 43.8. The alkalinity is caused by calcium, magnesium and strontium ions, carbonate and bicarbonate ions, and the molecular weight of bicarbonate is 61, molecular weight of carbonate is 60. The carbonate and bicarbonate alkalinity, it's never present in the same water sample. Now consider the total alkalinity and hardness relation. In the previous lecture, I told you about the relation of hardness and alkalinity. Now the hardness, it's caused by carbonate, bicarbonates, chlorides, sulfates and nitrates. But alkalinity, it's caused by only carbonates and bicarbonates and hydroxides. So when the alkalinity is less, then the portion of hardness caused by carbonates and bicarbonates would be equal to the alkalinity. That is, carbonate hardness will be equal to alkalinity, and non-carbonate hardness, it will be equal to total hardness minus carbonate hardness. That is, total hardness minus alkalinity. Now the next case is when alkalinity is greater than hardness. Then all the hardness will be caused by carbonates and bicarbonates. That's only carbonate hardness will be present and non-carbonate hardness, it will be equal to 0. And the total hardness will be equal to carbonate hardness. Now coming on to the numerical question. Question is, the pH value of water sample A is 4.4 and that of sample B is 6.4. Now calculate how many times one sample is acidic than other. Also find out which sample is more acidic. As you know, the pH is equal to minus log of hydrogen ion concentration. Now taking sample A, the pH of sample A is given as 4.4. Now put the value of pH in formula. 4.4 is equal to minus log of hydrogen ion concentration. Therefore, hydrogen concentration, it would be equal to 10 raised power minus 4.4 moles per liter. Similarly, for sample B, pH is given as 6.4. Again, put the value of pH in the formula. 6.4 will be equal to minus log of hydrogen ion concentration. Therefore, hydrogen ion concentration, it will be equal to 10 raised power minus 6.4. Now the concentration of hydrogen in sample A divided by concentration of hydrogen in sample B. It comes out to be equal to 100. What does it mean? It means that sample A is more acidic than sample B. That means sample A is 100 times more acidic than sample B because the concentration of hydrogen ions in sample A is more. So sample A will be more acidic. Now another question. The analysis of a sample of water shows the following results in mg per liter. The concentration of sodium is 20, means the concentration of sodium is 20 mg per liter. Potassium 30, calcium 70, magnesium 12, chlorine 40, bicarbonate 68, SO4 7, NO3 12. And the concentration of strontium is equivalent to a hardness of 2.52 mg per liter, and the carbonate alkalinity is 0. Calculate the total hardness, carbonate hardness, and non-carbonate hardness in mg per liter as calcium carbonate. Here the concentration of sodium, potassium, magnesium, calcium, chlorine, HCO3SO4 and NO3 is given. And the concentration of strontium, it's not given, but the hardness caused by strontium is given. That's equal to 2.52 mg per liter. And the carbonate alkalinity, it's equal to 0. And we have to find out total hardness of water, carbonate hardness, and non-carbonate hardness in terms of calcium carbonate. Now solving the question, the total hardness would be equal to the hardness caused by calcium, magnesium, and strontium ions. Now using the formula, hardness is equal to M2 positive into equivalent weight of calcium carbonate divided by equivalent weight of M2 positive. As you studied this formula earlier, now we would separately calculate the hardness caused by calcium, magnesium, and strontium ions. Now first the hardness due to calcium. It's equal to 7 into 50 by 20, where 7 it's the concentration of calcium ions as given in the question, and 50, as I told you, it's the equivalent weight of calcium carbonate, and 20 it's the equivalent weight of calcium. It comes out to be equal to 17.5 mg per liter. Similarly, the hardness due to magnesium, it's equal to 12 into 50 divided by 12.2, where 12 it's the concentration of magnesium as given in the question, 50 it's the equivalent weight of calcium carbonate, and 12.2 it's the equivalent weight of magnesium, and it's equal to 49.18 mg per liter. Now hardness due to strontium, it's directly given as 2.52 mg per liter. Now the total hardness would be equal to sum of hardness due to calcium, magnesium and strontium. It comes out to be equal to 69.20. As discussed in previous lecture, in the formula, total alkalinity as bicarbonate is equal to bicarbonate alkalinity into 1.22. So, the bicarbonate alkalinities as calcium carbonate here would be equal to 68 divided by 1.22. That is equal to 55.74 mg per liter. Here the alkalinity is less than hardness, as alkalinity is 55.74 and hardness is 69.20. So the carbonate hardness would be equal to alkalinity. That's equal to 55.74, and the non-carbonate alkalinity, it would be equal to total hardness minus carbonate hardness. That is equal to 69.20 minus 55.74. That's equal to 13.46 mg per liter. Now the next question. If the total hardness and alkalinity of a sample of water are 300 mg per liter and 100 mg per liter or on calcium carbonate scale respectively, then find its carbonate and non-carbonate hardness in mg per liter. Here the total hardness is given greater than alkalinity. As total hardness, it's 300 mg per liter and alkalinity is given as 100 mg per liter. Therefore, carbonate hardness, it would be equal to alkalinity, that is 100 mg per liter. And non-carbonate hardness, it would be equal to total hardness minus alkalinity. That is non-carbonate hardness is equal to 300 minus 100, that is 200 mg per liter. Now here are some questions and you will have to solve these questions by yourself. The first question is, the alkalinity and the hardness of a water sample are 250 mg per liter and 350 mg per liter as calcium carbonate, respectively. Find the carbonate and non-carbonate hardness of water. Next, a water sample has a pH of 9.25. The concentration of hydroxyl ions in the water sample is. Here you have to find out the concentration of hydroxyl ions. This was the end of this lecture. In the next lecture, we will study about chloride content, nitrogen content, dissolved gases, and the other metals.